so remember that when you're doing the hypotheses, then you want to read through the problem and you want to find some keywords. Specifically, I would be looking for something like more or less or increase or decrease, at least, at most, something along those lines when I read the problem. That's going to help me write the hypotheses. All right, so I'm going to read through this one. It says a researcher reports that the average salary of assistant professors is, and here is our keyword right there, so I'm going to underline that, is more than $42,000. A sample of 30 assistant professors had a mean salary of $43,260. At alpha equals 0.05, test the claim that assistant professors earn more, and there it is again, than $42,000 per year. The standard deviation of the population is 5230. Okay, so remember that when you were writing your hypotheses, that the null hypothesis always has an equal sign in it. So that is sort of fixed from one problem to the next. The null will always have the equal to. The H1 should show the keyword that you noted as you read through the problem. So it says that we want this thing to be more than 42,000. So more than, to me, is a greater than. Right, so more than 42,000. I'm going to put that same number in for the null hypothesis. Okay. Any questions on that part? I'm getting those two statements written from this paragraph. Okay, so the other part of step one, which we haven't done yet, is to identify the claim. We're going to write down next to one of these two statements what it is that we're trying to show. I'm going to take a picture of the problem so that you've got the problem. So for the claim, sometimes the problem makes it easy, and in this case it does, because they tell me I can find the word claim right here. So it says test the claim that assistant professors earn more than 42,000. So the claim is the one that's more. So that's going to be this one. All right, any questions on that? We've got our statements written. We picked out which one we're trying to show. All right, and you guys, we only got a couple of people in class, so you guys jump in if you've got questions or things that you need to ask. All right, so second step is the critical value. We also talked about that Monday. All right, so that is where you are drawing a curve and you are shading either left tail or right tail or both tails. So we said on Monday that the easiest way to decide how to shade was to look at the H1. So if the H1 has a greater than, that would tell me to shade on the right. So I'm going to section off a piece of the tail of the curve. and shade it in. So if the H1 has a greater than, that means shade on the right. All right, so then we use the alpha value. They're telling me that alpha is 0.05. Remember, that's the area of the shaded part of the curve. And my job is to find the critical value, the z-score, that sits right here, that separates shaded from not shaded. All right, so can you guys help me? What do we need to do first?
Subtract 0.0.
Great, thank you. So we're going to subtract that from 0.5. So I'm going to say 0.5 minus 0.05. That gives me 0.45, and I'm going to put it right here. Then I'm going to go to my table, and I'm going to try to find either 0.45 or the closest thing to it.
0.3505.
Yeah, so these are the two numbers that I can find in the table. And my number is right dead in the center, right? And so we said if we're right in the center, that we always go with the larger one. Right, so we're going to be using the 4505. And so my z-score is going to be 1.65. Okay.
Good.
All right, so I'm going to mark that off on the z, 1.65. All right, so again, that's what we did on Monday. Okay, does anybody have a question on either step 1 or step 2? Okay, you guys okay? All right, so moving on to step 3 then. All right, so step 3 is what we're going to call the test value. So what we're going to do is we're going to look in this problem and we're going to try to find where they're talking about the research that was done. Okay? So they're talking in that problem about, you need a pencil and paper, you need to write this down. It's hard. You have a pencil? You need a pencil?
Yeah, one.
Okay. Open right with my cut sheet. All right, so okay. So what I want to do is I want to kind of find the part of the problem where they're talking about the research that was done. So I'm looking at the second sentence that says that we have a sample of 30. Just going to kind of jot it down what they tell me. And they say that those people, those 30 people, had a mean salary of $43,260. So the average for those people is $43,260. So that's sort of the research that was done to either say, yeah, we agree with the claim, or no, we don't. Okay. All right, so those of you at home, make sure that you're listening when I talk you through this part. Right, so 42,000 sits right here in the middle. Okay, remember that we talked about on Monday, we talked about how the number had to be significantly bigger for me to get worried about, right? Like, if my number is 42,001, I'm not going to go to this person and say you're wrong, right? And if it was 42,002, I'm not going to say it's wrong. But if it was 50,000, I might go tell him he was wrong, right? Yeah. So we talked about this line right here being kind of like the dividing line between, I don't care, 42,000, 42,001, 42,002. I'm not concerned about those numbers. But as I get past the line, we're saying, okay, that's big enough that we're going to go tell him he's wrong. Okay. So the research is showing this number. So what I need to figure out is which side of the line is 43,260 on? Okay, is it in this part right here where I'm saying I don't care, or is it over here where I'm saying I'm going to go tell him this wrong? Problem is, the only thing that I can compare it to is that z-score of 1.65. So I don't really know until I convert it. And so that is what we're doing in step 3. We're going to take this 43,260 and we're going to convert it to a z-score. Z-score. Then I'll know which side of the line it's going to be, right? Because I can compare it to the 1.65. Now, we've been converting to z-scores forever now, right? That's that value minus mean over standard deviation formula? Okay. All right, so look up here at the top of the screen. So the formula is that. That is the same formula that we've been using all semester, okay? So this formula in words is just what we've been using. Value minus mean over standard deviation, and then the square root of n. Now, I do have to do the square root of n because we're talking about a sample of 30. But I wanted you to see the symbols because there's 2 issues that you've got to really pay attention to here. Okay, the first is that you've got to be sure that the numbers on the top of that formula are right, in the right order. Okay, this X with the bar over it is the mean of the sample. And you got to be sure that you put that first. Because there are 2 averages in the problem, right? They're talking about an average salary of 42,000, and then they're talking about a mean salary of 43,260. So you got to be able to tell those 2 apart and get them in the right order. That's the first thing students have a really hard time with. Okay, the second thing that you've got to watch out for is this symbol on the bottom. This is standard deviation, but it's standard deviation of the population. You've got to be sure that you have standard deviation of the population and not standard deviation of the sample. If you have standard deviation of the sample, we're going to work the problem differently. We'll do that in the next section. But for now, that's the other thing that causes problems. Okay. All right, so let's see if we can get these numbers plugged into my formula. So the first number that goes into that formula is the mean of the sample. So is that the 42,000 or is that the 43,260?
43.
The 43. Okay, so we kind of write that down. We said a sample of 30. The average for those people, that's the mean of the sample. All right, what's the regular mean?
42,000.
42,000. Okay, now, my best advice is that the number in the hypothesis over here should be the second number over there, every time.
So that again?
This number that's in the statements goes second, always. Okay, so that's a good way to sort of check yourself and make sure you don't have those numbers switched. Okay, standard deviation of population, they tell me that, the standard deviation of the population. So we're good there, 5230. And I'm going to divide by the square root of 30 because I have 30 in my sample. All right, so we need to put this in our calculator. We've done this before. Remember that you need a parenthesis around the top and a parenthesis around the bottom. Okay, what'd you guys get up?
1.3, 1.9, well, it's 1.32.
1.32. All right, do we agree with that? Those of you at home, 1.32. Sound good?
Yes.
1.32, good. All right, anybody have a problem or a question on step 3?
Yes, I didn't.
Okay, say that one more time.
I didn't get 1.32.
Okay, so when you put it in your calculator, let me just try to write it down up here. You're going to do a parenthesis and then 43 to 60 minus 42,000, and you're going to close the parenthesis. And then press your divided by key. You're going to open another parenthesis, 5230. You're divided by key again. That second divided by is typically the problem for most students. If they get the wrong answer, they forgot that. And then the square root of 30, and then close that parenthesis. All right, so what I'm going to do now is I'm going to take that 1.32 and I'm going to mark it off on the curve. All right, so where is 1.32 on my curve?
You mean like on the left?
Yeah, it's going to be the left or the right of 1.65?
Left.
Left. Okay, so 1.32 is here. Remember that that's your other average. That's the 43,260. There's one average. There's the other one, 2 blue marks. Okay. All right, so step 4, you're going to start making conclusions. So in step 4, we're going to either say reject the null, or you're going to tell me do not reject the null. You can't really say anything else. Okay, so those are going to be your choices for your conclusion on step 4. Either reject the null or do not reject the null. Okay. So here's my question to you. Is 43,260, when I made this blue mark right here in the curve, is that far enough away for me to be worried about it and to go tell somebody that they're wrong? No. So the null says that they're the same. They're equal. I'm agreeing with that. I'm saying they're basically the same. I'm not getting worked up about that difference because it's not a significant difference. Yes.
So if it was like, say, 1.70 or something like that, then we would vary.
So if it's 1.70, then yes, the null says they're equal, we're saying no, they're not, we would reject.
Gotcha.
Okay. All right, so in this case, the null says they're equal, we're saying, yeah, we agree. So I'm gonna say, do not reject the null. Let's let that finish it, but that's gonna be what I'm gonna say, is do not reject the null on step 4. So go ahead and write that down. Hopefully my computer's not-
We can't see your screen.
Okay, hang on just a second, it's doing something weird. See if I can get it to come back. Give me a minute, I'm working on it. All right, should be back, but we lost the ink. All right, you guys can see the screen now? All right. Okay, so we had said, I'm just gonna kind of pick up where we left off. We had said, do not reject the null, and that should be step 4, right?
Right.
Those of you at home, you can see it now, right?
Right.
Okay. All right, so then step 5 is the conclusion, right? And we're going to use a chart in our book, and I've got it on the next slide to help us write the conclusion. And the conclusion is always a hard thing for students to do, but it's hard because they don't have the chart sitting in front of them when they take the test. But you guys are going to have the chart sitting in front of you when you take the test. So hopefully step 5 is going to be super easy for you to deal with. All right, so let me show you this chart. I would suggest you take a picture of it and maybe later transfer it into your notes so that you've got a copy. This is going to help you write that concluding statement for step 5. So you're going to base your conclusion on 2 things, right? So you help me because I don't have my ink anymore. All right, so the first thing I need to do is I need to look at step 1 in my problem. And where did I put the claim? Was it on the H1 or on the H0?
H1.
H1, okay. So if my claim is H1, that tells me I'm going to be working with one of those 2 boxes. Okay. And then I'm going to look at step 4. What did we say in step 4? Reject or do not reject? Do not reject, right? All right, so that tells me that this is the statement that I want to use for my conclusion. And I'm just going to copy it down for step 5. Okay, so there is not enough evidence to support the claim. All right, so I'm gonna go back to my other screen and write that down. Not enough evidence to support the claim. That, and then I need to finish that statement. All right, so to finish that statement, I simply look back at my hypotheses and I just read basically from the claim. So I start here and I'm going to say average. Okay, average, let's see, what are we talking about? Average salary. Okay, and then I'm back to my average is greater than 42,000.
I got a question.
Yes.
Can you go back up? Do we know to reject, not reject the norm?
Yeah. Okay, so our picture, we had a critical value of 1.65. And when we calculated our test value, we got what did we get? 1.32.
32.
Okay. So when I go to mark off that 1.32, I'm going to mark it off between 0 and 1.65. Okay. You okay with that part? Okay. So now when I look at those two marks, I'm saying to myself, these are the same. Okay, I'm not saying that they have to be exactly the same number, but they're not far enough apart that I'm going to worry about. Okay, it's not enough that I'm going to go to this researcher and tell him he's wrong. Right, so the null says that they're equal. We're saying that they're equal because we're saying that they're the same. So we're basically agreeing with the null. And so we would say, do not reject the null.
Okay, so what number, like, does it have to be higher for us to far apart?
This is your dividing line. So if your number had been 1.7 instead of 1.32, you would have marked it off over here. You would have said these are not the same. And you would have rejected the null. The null is always going to say that they're equal. So you just start deciding, yeah, I think they're equal, or no, I think they're different. Right, remember the dividing line is the shaded part. Okay, so let's try, hopefully today, we'll see how we do on time. We're going to get through a couple of these so that you got a little bit more exposure and practice. It does get easier as you do them. All right, so let's go to another one. All right, so again, take a picture. This is way too much for you to write right now. Take a picture of it so that you've got a copy. You can write it down later if you want to. Okay, so I want you guys to work on hypotheses for me. Let's see what you come up with. All right, so remember that you are reading the problem and you are looking for words like more or less or greater than or increase or decrease. Remember that your H1 hypothesis can either have a less than, a greater than, or a not equal to. Those are your only three options for the H1. Okay, so I'm going to let you read through it and you look for a keyword. See if you can find a keyword. Okay, so if I was going to use a less than, then I would be looking for words like less or decrease. Do you see a word like that in the problem? Anybody see a word that makes you think less than? I don't. See anything less than, smaller than, decrease, anything like that? Okay, so I'm thinking it's not that. All right? If I'm going to do a greater than, I should be looking for words that say more or increase or bigger. Do we see anything like that? No.
No.
Okay, so that only leaves the not equal to. So just kind of by process of elimination, you can get to that hypothesis for the H1. Okay, so the H1 is going to have that symbol. The H0 always has the equal to. Right now, what number goes into that? Yeah, the 24,672. Okay, so my other class struggled a little bit here. This right here that's the research. Okay, I mean, he's talking about pulling a sample of 35 and getting the average for those people to be 25 to 26. Okay, that's the research part. That's going to be step 3. But the accepted average overall is that other number. All right, so now I'm going to look for the claim part. Okay, now the best scenario is that the problem actually has the word claim in it, because that makes it easiest for me. But this one doesn't. So if it doesn't say the word claim, then I'm going to look at the question, because I want to be sure when I'm done that I've actually answered the question. So the question says, can it be concluded that the average cost of stroke rehabilitation in a particular hospital is different from 24,672? So which one of those statements shows that it's different? The equal or the not equal? Which one would be a difference?
Not equal.
Not equal. Okay, so I'm going to put the word claim by that. Okay, and then we're ready to move to step 2. Anybody have a question on the statements? All right, so step 2. How did I know what?
How did you know that was different?
Because the question says that we want to show that it's different from
Mhm.
24,672. So the first statement says that it's equal to 24,672. We want to show that it's different.
Okay.
Okay. So how does it shade? How do you shade this one? Left, right, or both?
Say, yeah, I think it's both.
Both. Okay. So remember, you're looking at H1. If H1 has a less than, you're shading to the left. If H1 has a greater than, you're shading to the right. If it has a not equal to, you're shading both. Okay? So both tails should get shaded on the curve. All right, they're telling me that alpha is 0.01. Okay, so what do I need to do? You guys remember from what we talked about Monday? What do I need to do to find the critical value?
Divide by 2.
Divide by 2, because we have two sections on the curve that are shaded. So I'm going to divide by 2. That's going to give me 0.005 for each side. Okay, remember, only divide by 2 if you've got two sections. All right, then what do I do?
Subtract from
Subtract from 0.5. So 0.5 minus 0.005 gives me 49.50. And that goes here. And then we're going to the table. We're finding 49.50 for the best estimate that we can have. What are we looking at there for a z-score?
2.58.
2.5.
2.5.
2.58. All right, any questions with that part?
I thought you said number by number.
Anything else? All right, so let's move on then to step 3. So step 3 is where we're getting that research, and we're going to plug into the formula and get our test value. Okay, so help me with the plug-in. So anything that you know specifically, it goes in a certain spot.
Starts off with 25, 226.
Good. Starts off with the 25,226.
Minus the 24, 672.
Okay.
And 3,251.
Uh-huh.
Divided by square root of 35.
Sure. Okay. All right, is everybody okay with that? Again, the best thing I can tell you for the order on the top part is for you to go back to your statements over here, and this number goes second on the top part of that formula. Okay. So kind of check that, make sure that you've got those numbers in the right order. All right, so let's put that in our calculator and see what we get. All right, so I get 1.01. Does that sound right? Okay, so I'm going to mark it off on the curve. So I know 0 is in the middle. And 1.01 is pretty close to 0, right? Not past 2.58. So maybe somewhere like right about here. Okay. So those two marks, those two red marks, are you saying that they're the same or you're saying they're different? Same. Okay, not far enough apart to be considered different. So these are the same. When does it become different?
Reaches the shaded part.
When it reaches the shaded part. Good. Okay. So no hypothesis says they're equal. We're saying, yep, we agree, they're the same. So what are you gonna say for step 4?
Well, do not reject.
Do not reject the null. Okay, and then I think your conclusion is gonna run along with the one what we did on the other one.
Yeah.
So there is reject the null, so there's not enough evidence to support the claim.
Right.
That the average. What are we talking about here? Cost, average cost. Is not equal to. $24,672. All right. Anybody have a question on that? Okay, we just have a couple of minutes, so I don't really have time to work a completely separate problem with you, but I want you to see this one because you're going to see some of these in your homework where they're giving you the numbers and making you do some calculations on it. So the only thing that you're missing on this problem is the mean of these numbers. So this is your research.
So we have to find a mean.
So you're gonna have to find the mean. How do you do it?
Add them all together and divide by the number.
Right, add them all together and divide by the number that you have. All right, so I've done this already. Let me see if I can get it back up here. All right, so when you add them together, you get 2,700. There are 36 numbers. So that gives you a mean of 75. Okay, and that's the only part that you're missing. Okay, so what I want you guys to do, we have a couple of minutes. I want you to do, let's get started on it. We won't finish it, okay? But I want you to do the hypotheses for me. So go through.
Miss Jennifer,
Yeah, go ahead.
at the end, can you go back to the last slide on step 5?
Yeah, Amaya, just remind me, okay?
Okay, thank you.
All right. All right, so look for a keyword in there, see if you can write me a hypothesis for that one.
Can't read it.
All right, so do we see a keyword? Let's see, less than, okay, yeah. All right, so that tells me that one of my H1 should be less than 80. The H0 should be equal to 80 because it always is, right? Equal. All right, which one's your claim?
The second one.
A researcher claims that the average cost is less than 80. All right, everybody okay with that part at home? Okay, what's your picture look like? Shaded how?
To the left.
To the left.
On the side.
All right, so can you find your critical value for me?
Is it 0.28?
Yes, okay, so good, so we would say 0.10 over here, subtract from 0.5. Would we get 0.4000?
Right.
Closest thing in the table is 3997, which is gonna correspond to negative 1.28. All right, formula. What goes where?
Is it 81.75?
Okay, is it 80 minus 75 or is it 75 minus 80?
75 is the mean.
Remember, this number goes where?
That's the value.
That's the back number,
Value.
second number. Okay, so the 80 goes back here. All right, so the 75 must go first, right? All right, standard deviation is, what is right here? 19.2.
Square root 36.
Divided by the square root of 36. All right. Pop this in real quick. All right, negative 1.56 is what I get. All right, so I'm going to mark that off on my curve. It's going to end up being way over here. Okay, so are you saying those two numbers are the same or different? Those are different, right? It's in the shade region, those are different. Null says they're equal, we're saying they're different, so we're gonna do what with the null?
No,
Reject.
Reject it. All right, and I'm gonna stop there. You can get the statement off the chart. Okay, questions?